Okay, so this is page 83, number 34. So this is a hard problem. It's a blue problem. So let's draw the picture first. And the picture is there is a man kicking a ball, and it has an initial velocity in this direction, and that theta is equal to 53 degrees. And it comes over here, and it is going to go onto a playground on a roof. And let's just say that, like from the information in there, it says that this is 1 meter above, so this is 7 meters, and this is 6 meters. And it tells me the distance from here to here, and that was 24 meters. Alright, I'm gonna call this H, and I'm gonna call this D. Let me get some space here. Alright, and what other information do we have? So we have the T is equal to 2.0, T is equal to 2.20, and that's seconds, and that's for over the vert of the wall, so over the vertical wall. Alright, so just so I can conceptualize this, as the ball, it's going to clear that 1 meter path, and we don't know how much it's going to clear it by. That's going to be part of the problem. And it says that that the 2.2 seconds is the time where it clears the 7 meter wall. So let's start in on the problem. The first question says find v sub 0. So I want to find v sub 0. So to find that, well, we know d is equal to 24, and we know the time is equal to 2.20 seconds. So I can just use the constant velocity in the x direction. So I'm going to let you guys figure this out. So with the velocity that I'm going to use, I'm going to look at in the x direction. So this is my v sub 0, and I want to figure out what that is, but I have a component of v0x, and so I just want to really hit home that whenever you have in the x direction and you have this angle, you need to break it up into its component. So that's v0 is equal to v0 cosine of 53. Alright, from there, when you have that, you're just going to set this equal to d over t. Know it, know it, know it, solve for it. So you're going to solve for this guy right here. Alright, so that was part A. So hopefully you guys can finish that off. Part B, now it's starting to get a little bit trickier. So part B says we want to find by how much it clears the wall. Wait, hold on, let me see what B says. B says find the vertical distance which the ball clears the wall. Alright, so what I'm trying to find is I need to find delta y at 2.2 seconds. So I want to find out how far up is this? How far is delta y when I'm at 2.2 seconds over this vertical wall. So to do that, I'm going to use my equation delta y is equal to v0 y times time minus 1/2 gt squared. And remember, like, the key thing that I want to point out here is that whenever you have in the y direction, we need to break that up into our components. So the component in the y direction is v0 sine of my theta. Alright, so I'll let you guys solve that too. When you get this answer, that answer is going to give you the total height, but you need to subtract this answer. You need to subtract 7 off of this to figure out what your so your final height is your delta y minus your h will give you what it clears. So delta y minus h will give you the height above the wall. Okay, so not too bad here. Let's give us some space. Alright, so I'm going to put that over here. Alright, so C is actually really tricky. So I'm not going to solve the whole thing for you guys. I want you to really think about it. But what we're trying to do is we're finding delta x. So we are finding x for the last part of the fight. So my game plan is to find the height, or find the time it takes the ball to fall from the height above the vertical to, and here, like, we're finding the time it takes for it to fall from this height above the wall to the 6 feet. So we're finding this total, the time it takes for it to fall from here to here. So from the height above the vertical to the roof. And so note that you're going to have to use that the roof is 6. So so that's going to be part of how we're going to solve this. Alright, so the time for it to drop, now this is where, like, in class we practice doing the quadratic formula, and you actually have to solve this with the quadratic formula, because if we set up our formula, delta y is equal to v0 y times t minus 1/2 gt squared. So I'm trying to find the time, and the delta y, if we find the time for it to be at 6 meters, so right here, so I want to figure out what this time is. So the time for it to go from the vertical to 6 meters. So I'd have 6, and then I'll let you guys figure out the v0y times t. I guess the big thing that I want you to realize is that whenever it's v0y, it's going to be your v0 sine of 53 degrees. So multiply that times time minus 1/2 gt squared. And this v0 you solve for in the first part of this problem. So we have that, and whenever you find out your time, you're going to find, so essentially what you're doing here is you're finding the time where the ball is at 6 meters. So a quadratic is going to give you two times. So it's going to give you, so if you think about the path, it's going to give you this time, and it's going to give you this time over here. Well, we don't want, this is the one that we're looking for right here, when it's 6 meters in the second part of the path. So when you get the two times, you're going to take the later time because that's the time where it's 6 meters on the downward path. So when you get this, the time, this is going to be, when you find the time for it to go this last bit from the very top over the vert to where it hits the 6 meters. To do that, you're going to say that your time for that last part is going to be your 2.2 seconds. Whatever you find here minus your 2.2 seconds. And that 2.2 seconds was the time for it to go here. So you're finding the total time minus the time for it to get here. And so then that just gives you the time it takes for it to go from here to here. So once you find that time, now it's pretty straightforward. When you have the time where you know that velocity, here let me write it like this. You know that constant velocity is equal to delta x over t. So you're trying to solve for delta x, you are looking for t, and the good thing about the x direction is that it is constant. So what you're going to have is v0x, and multiply t over here. So really I should say v0x. So times t is equal to my delta x, and this v0x is on the subnotation. So to find that, and just remember that your v0x was your v0 from what you found in the first part, and in the x direction it's your cosine, and that's 53 degrees. Multiply that by the time, whatever time you found here, that's going to be the time it took for it to travel that distance, and that's going to equal to your delta x. Alright, should I just give you the answers so you can check your, yeah, I think I'll do that. So I'm going to give you guys, just so you can check your answers when you calculate it, you should get, for part A, you should get 18.1 meters a second. For part B, you should get 1.09. Wait, let me see real quick. Yeah, you should get 1.09 meters. And for C, you should get 2.8 meters. And it's just a good note to like think about whether your answers make sense. And 18.1 meters a second, okay, that's kind of hard to visualize. But up over here, you would guess that it's not too far over the vert. Well, 1.09 meters, like just over 3 feet, like that sounds about right. And then it's clearing 2.8 meters, well, that seems about right too. If you would have gotten like 15 meters, then like, oh wait, that's way too far. If you would have gotten like 10 meters high, like, well, that's has to be a really strong kick. So these make sense, and I don't think I made any errors, so that should be the right answer. Okay, hope this helps. This is a really hard problem, so don't let it discourage you.